Okay. Okay, this is for the finite slope. Okay, a general explanation by Das. Okay. So you can read the explanation by Das. Okay, when the value of CI approaches the height of the slope generally may be considered finite. The possibility when analyzing stability of finite slope in homogeneous, we need to make assumption about the general shape of the surface of potential failure. Although considerable evidence suggests that the slope usually occur on the curved failure surface, Pullman approximated the surface of potential failure as a plane. Okay, the safety is calculated by using Pullman approximation. Give fairly good result for near vertical slope only. Okay, so this is for the limitation of the Kuhlmann, which is the one that we use the linear failure plane approach. Okay, after extensive investigation of slope failure in 1920, the Swedish Geotechnical Commission recommended that the actual surface of sliding may be approximately to be a circular cylindrical. Okay, so that this is the evolution that's been made by a Swedish Geotechnical Commission. Okay. So at least you understand how the background of the analysis. Okay, for the first one they use the Kuhlmann. Okay, until after 1920, okay, they use the circular cylindrical approach. Since there's most conventional stability analysis of slope has been made by assuming the curve of potential sliding is an arch of a circle. However, in many circumstances, for example, zone, dam, foundation, or etc., stability analysis using failure plane study is more appropriate and yield excellent result. Okay, so that is depends on the condition. Okay. However, nowadays we have a lot of geotechnical software. Okay, so let the software determine the type of the failure, but we need to understand the fundamental of the analysis. Okay. Okay. So okay, based on the Kuhlmann method, okay, I guess the same explanation, okay, from what we have discussed previously. Okay. So we need to determine the W and A T A, okay, to determine the factor safety value. Okay. So this is the equation based on sigma and tau. Okay. So you can go through this in detail. Okay. But I guess the same approach or the same explanation from Dr. Noli Gofar. Okay. Okay, but this is they have a more an additional explanation, okay, on how they determine the theta critical, okay, which is beta plus phi d over 2. Okay, so you can look on this explanation. Okay, so try to get the value of the theta. Okay, I also not pretty sure how they get the theta value. Okay. The first derivative of CD with respect to theta is set to equal to 0. So they put this as a 0, then they do the calculation. Okay, to determine the what we call as the theta. Okay. Okay. So then they get the theta is equal to B beta plus pi d over 2. Okay. So then substitute the theta in the equation to get the new CD. Okay. So then from the CD, they obtain the HCR. Okay. By putting arranging the HCR on the left and the rest on the right. Okay. So now we look for one example from dust. Okay. A cut is to be made in the soil having gamma equal to 105 pound per feet cube. Then C is equal to 600 pound per feet square and phi is equal to 15. Okay, the side of the cut slope we make an angle. What should be the depth of the slope that we have a factor safety equal to 3. Okay. So then the solution is the phi is equal to 15. Okay. C is equal to 600 pound per feet square. Okay. If factor safety is equal to 3, then FC is equal, then FC and FC should also be equal to 3. Okay. So this is what has been we have seen in example Dr. Nolly in the speech in the equation, sorry, in the problem number 5.3. Okay. So then the CD that we should introduce is C over factor safety is 200. Okay. And then similar with the phi, okay, tangent phi over F phi is equal to 15 over 3, which is 5.1. Okay. Then we include all the value in the equation to determine the H, okay, where the H is equal to 23.05. Okay. So that is for the height that could be made by using the factor safety of 3. Okay. So means that if we do this kind of cutting for the beta is equal to 25, okay, 45, okay, so we have a safe slope structure because the factor safety is greater than 1.5 or equal to 3. Okay. Okay. So that is example in DAS reference book. Okay. So we go for another example in Dr. Kamaruddin, which is I not provide yet at in the e-learning. Okay. So I will include it hopefully by this afternoon. Okay. Okay. This one. Wait. Okay. Okay. Slightly different from Das and Dr. Nuli reference book. Okay. So in this case, Dr. Kamaruddin used force polygon methods. Okay. So we see what is the difference. Okay. So I will share with you these notes and example later on. Okay. So the type of failure occur when a field of embankment, okay, has a weak plane. Okay, this is what I have been told previously. Or when there is excavation layer soil and the layer direction is downward to the excavation. Okay. So force polygon may be utilized to analyze slope stability. Both the example of slope and the force polygon are shown in figure 3.4. Okay. So this the same failure pattern. Okay, however, a different type of solution. Okay. Okay. So this is the potential failure plane. Okay, this is the block of failure. Okay. So we use the force of polygon. Okay. where we identify there will be three type of movement of force happen. For example, for the CR, okay, uh, which is the force is going on the failure plane, okay, moving similar with the failure plane, okay. So there will be a W which is going moving forward, moving downward to the due to the gravity force, okay. And there is a P value, okay, which is a normal stress acting on the failure plane, okay, which is the P, okay. So for each force, okay, it has a certain degree of opening. Okay, for example, 90 degree minus theta, okay, then theta minus phi r, and also 90 plus phi r. Okay. So how could we use this approach? Okay, so there are some procedure here. Okay, so this is the notation that explain what is the meaning of each notation. Okay, then we may refer for this procedure. Okay, where we use the same approach. For example, to determine the FS phi and also FSC. Okay, so we need to make sure that FSC is equal to FS phi. If FSC is not equal to FS phi, then we need to run for another assumption of the FS phi, okay, to ensure that FSC is equal to FS phi. Okay, at least we need to run 3 attempts, similar to what we have discussed on Dr. Noli example. Okay, so this is the procedure. Assume a failure of FS phi, then calculate for the phi r. Okay, so then this phi r we will use to determine the CR. Okay, so the CR is actually the capital CR, not the small letter of CR. Capital CR is equal to CR times L. Okay, so from there we can get the FSC, where we determine the small letter CR is equal to capital CR over L. Okay, so then compare the result between FSC and also FSP. Okay, so in order to obtain the CR, okay, we need to calculate for the W. Okay, so then we can determine the CR. Okay, how to determine the CR? Okay, I will show you by using this by draw a figure. Okay, stop. Okay, okay, okay. So for example, this is CR. Okay, this is the W, while this is the P. Okay. Okay, for each notation, it has the opening, it has the degree of opening. Okay, 90 minus theta, theta minus phi r, phi r, and 90 plus phi r. Okay, so once we determine the W, okay, so we may use the sine law. Okay, so W over sine 90 plus phi r is equal to CR, capital CR, over theta minus phi r. Okay. So this is the calculation. As this is the way that we can determine the CR, okay, by using the sine law. Okay. So W we should determine first, and then we determine the phi r based on the F as phi, okay, equal to tangent, tangent, tangent phi over tangent phi r. Okay. So then we can get the phi r by assuming any figure for any number for the fs phi. Okay. So theta is provided. Phi r we obtain from this calculation. Then we can get the CR. Okay. So later on, CR is equal to C R small letter over L. So easily we can get the C small letter of C R. Okay. So then to get the FSC, okay, the C should divide with the CR. Okay. Okay. So I will show you one example based on this what we call as approach. Okay. Stop. Okay. So we look on the first example. Yeah, one of example in Dr. Kamaruddin reference, okay, book. Okay, so this is example. Okay, however, slightly uh, difference. Okay, where the top of the slope it has a degree. Okay, okay. On the top of the slope, there has another slope. Okay, which is equivalent to 10. Okay. So then we have here 60, which is the slope angle, while 45 is the potential slope failure plane or surface. Okay. So then the question is determine the factor safety using plane failure method. The soil parameter are 18, C14 and V30. Okay. So the first is we need to determine the W. Okay. What is the value for the W? Okay. So before we start, okay, we should determine what is the length of the BE and also the BD, okay, to get the W value. Okay. So for the BE, okay, so for the BE is equal to 6 over sine 60. So it is a simple trigonometry methods, okay, where we determine the value of okay, okay, then okay, then we obtain 6.93. Okay, okay. For the next for the next step is to determine the BD. Okay, so what is the length of this BD? Okay, so to determine the length of the BD, okay, we should also use the sign of law approach. Okay, so we draw the problem first. Okay, so hope you still remember the sign of law, the sign law. Okay. So this is the line to represent the BE. Okay. Okay, so this is the line to represent the BE. Okay, then we have another line, okay, to represent the BD. Okay. Then the last line is the BD. Okay. So we already determined the line of the BE, which is equal to 6.93. Okay. 6.93. Okay, so this is the BE line. Okay, so how to get the BD? Okay, so we should use the sine law. Okay, where the BE is equal to 6.93. Okay, should sine. Okay, we should determine what is the degree of this one. Okay, equal to BD, the one that we want to determine. Okay, over. So we need to get what is the degree of this angle. Okay. 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 So the degree of the slope on the top is 10. Okay. While the slope angle is equal to 60. Okay. While the potential failure is 45. So it makes this slope or this degree to become 15. Okay. Okay. So the next step is to determine what is the degree for this opening and also this opening. Okay, because we want to put on this value. Okay, so first we begin with this one because we have the information of 10 and also the information of 45 here. Okay, so as usual, this degree is equal to the another opposite degree. Okay, so for this case, okay, when we draw a line there, so this should be 45. Okay, this should be 45 in total. Okay. Okay, another way, okay, another is concept of degree uh in a line. Okay, so if this 10. Okay, so this also should equal to 10. Okay, so for this case, this value is equal to 10. Okay, so 10 minus 45 minus 10, so this should be 35. Okay, so we already obtained 35. Okay, for the first degree that we want to get. Okay. So the total of a full triangle degree is 180. Okay. So 180 minus 35 and then minus 15. Okay. So we obtain 130. Okay. So then we can get what is the BD value. Okay. Okay. So you may let us look on the recorded version. Or if do you have any question before we move to the solution?
Clear.
Okay. Okay. Then we solve the problem. Okay, we solve the problem. So we obtain the BD is equal to 9.25. Okay. 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 That is the value for the BD. Okay. Okay. So the next step is to determine what is the weight of the wage. Okay. So this is the formula. Okay. You may try to find in any reference book. Okay. To determine the shape of this an irregular type of uh, triangular shape. Okay. 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 So then the value of the W is 149. Okay. Okay. Or you can use, is it same? We look on the W. Okay, the W. Okay, okay, the W. Okay. Try to look on this equation. Is it same with the one that show in this example? I guess it's different. Okay. So uh, if or you can use this formula and then try to try to compare with the result from this example. Okay, later on. Okay. So then we do a try and error approach. Okay. Okay. The Fs is equal to 1. Okay. Okay. For the phi r, tangent firstly we assume that Fs is equal to 1. Okay. The tangent phi times tangent phi over Fs. Okay. Then we obtain phi r is equal to 30. Okay. So based on the first polygon, okay, the same that we have discussed previously, okay, we include all this information, okay, to obtain the CR. Okay. So the CR is equal to 44.6. Okay. CR is equal to L, and then small letter CR is equal to 4.8. Okay. So FSC is equal to C over CR, okay, where FSC is equal to 2.9. Okay. Then we found that the FSC is not same with the first attempt of the FSV. Okay, so what should we do? Then we may continue for the second attempt. Okay, so repeat the same procedure. Okay, FSV is equal to 2. Okay, then we obtain 16.1. Okay, for the phi value. Okay, then we determine the CR from the first polygon. Okay, from there we obtain the CR is equal to 8.1. Okay, so FSC is not equal to FSV. Okay, so in that case we need to repeat another attempt. Okay, so the third attempt, okay, which is enough, okay, which is sufficient to determine the relationship. Okay, so for example, the FS5 is equal to 3. Okay, then we obtain 10.9. Okay, then we work out to determine the CR. Then we obtain 85.2. So FSC is still not equal to FSV. Okay, so then we may plot for we may we may plot for the relationship. Okay, so in this case, Dr. Kamarudin has included another value which is 1.5. Okay, which is equal to 2.0. Okay, then for this relationship, okay, we need to construct for line of equality. Okay, so the intersection between the line of equality with the relationship is equal to the vector safety. Okay, which is in this case 1.8 is the value for the vector safety. Okay, So you can try to use 1.8, okay, and then get the result for the FS5, FSC later on. So for example, try FSV is equal 1.8. I guess hopefully you can get the FSC is also equal to 1.8. Okay, so that is for linear failure plane. Okay. Any question before we move to to the total stress? Okay. So no question. So then I move to several example on the total stress. Okay. 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 I have discussed this before. Okay. Okay. We look on some of example. Okay. An excavation was made. Okay. Uh, to depth of 6 meters, forming an angle of 35. Okay. The soil is cohesive with Cu equal to 25 and the phi is equal to 0. Unit weight of the soil is 20. Okay. First, use a figure 5.5 to get the first approximation of the failure plane for the slope. Okay. Then find the failure safety of the slope is the weight of sliding is 983 kilonewton. And the center of gravity of sliding is at a horizontal distance 3.95 meter from the point 0. The radius of the circle is 10 meter. Okay. So we need to refer to figure 5.5 first before we start the calculation, because we want to determine what is the theta value. Okay. So based on figure 5.5, if the beta is equal to 35, okay, 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 okay. For example, if the beta is equal to 35, so your theta is equal to 26, and your delta is equal to 35. Okay. So now we need to determine what is the delta. Okay. So actually we need to construct for the diagram first to determine the theta. Okay. So in this case, okay, after they uh, sorry 35, under 80 minus alpha minus beta minus delta. I'm not sure how come they get 84. Okay. Unless if we can if we construct first for the full diagram, okay, because it's not easy just 180 minus 26 minus 35 and minus 35, then we get 84. Okay, okay. It's not a very straightforward calculation unless we construct the diagram, then use the protector to get the delta. Okay, but we just use the value first. Okay, so we assume the theta is equal to 84. Okay, then from there we may calculate for the factor safety. Okay, where Cu is 25, La, okay, which is the length, the R times with theta. Okay, in this case theta is equal to 84. Okay, while the R is equal to 10. Okay, so R theta means that R 10 times, okay, 84 times pi over 180. Okay, that is for LA. While for the R is 10. Okay. However, Dr. Noli, she has used 2 over 360, which is same, which is equal to 180. Okay. So pi times 10, which is R, times another R, which is 10 square, times 84 times pi over 360. Okay, so that is for the CULAR. Okay, divide with the weight of the mass 583 times with 3.92, which is the horizontal distance. So the factor safety is equal to 1.57. Okay, so that is the solution for the problem 5.5. Okay, so this is another example. Okay, where it has a tension crack and the tension crack is filled with water. Okay, so in order to determine the factor safety value, okay, so we should determine first the beta, okay, where the vertical, one vertical, two horizontal, then we can get the beta is equal to 26.5. Okay, so the undistant is 35. Okay, then could we could not use this formula, then we need to include the tension crack as well in this solution to solve this problem. Okay, so I guess I can go a little bit fast. Okay, so okay, to get the value for the PW, okay, so we need to draw. Okay, I will show you how to draw it. Okay, we need to draw a pore water pressure diagram. Okay, okay. So we need to draw a pore water pressure diagram. Okay. Okay. The height, the depth is 3.3. Okay. So definitely the stress will be increased with depth. Okay. So then we need to know what is the pressure at this point. Okay, which is 9.81 times 33.3. Okay. Times 3.3. Okay. So then we know what is the value for the stress at that level, 9.81 times 3.3. So we obtain 32.37. Okay, so that is the value for the stress. Okay, then we determine the PW. Okay, the PW is the area for this distribution diagram. So half time 3.3 and then time 32.37. Okay, So that is the way how we determine the PW. Okay. Sorry. Okay. Okay. So from there, okay, Dr. Nolly obtained 54.35. Actually, it's not 54.35. Okay, so you can try to calculate, and then I guess the value is 53 something. Okay, so then later on we determine the LA. Okay, due to this tension crack, the LA, the effective length has been reduced, so it becomes 83.1 degree. So the LA is 33.11. Okay. So from there, we calculate the factor safety. Okay. Actually, there is a slightly different, they have an error here in the calculation, but the value that has been written in this example is 1.15. Okay. So please check again. Okay. And then you need to do some amendment on this example. Okay. So the YC, okay, is the moment arm, which is 12.2, and then need multiply with the PW. Okay, so PW is this is 54, not 4. Okay, so there are some error in this example. Okay. Okay. So please look again on this example. Okay, make sure that you understand in terms on to check the stability of this by using the total stress and push. Okay. So that is example for Dr. Noli. Okay. So I move to our last example based on Dr. Kamarudin. Okay. Before I finish, I need to share the attendance list. Attendance form. Okay. Okay. So I will give this example later. Okay. I need to go a little bit fast, okay, because it is just a repeated solution, okay, because most of you know how to solve the problems, okay. Okay, so we have here W1, W2 because they have two layers. Actually, it is not a circular type of failure because it is a non-homogeneous type of soil because it has two type of soil. Okay, however, for the sake of the example, okay, so we just assume it is a circular type of failure. Okay, so this is 35 in terms of the opening size for this this circular arch, and 80 for this BC. Okay, so we identify that the W2, the location is located at the perpendicular to the point of origin. So definitely there are no moment arm. So in calculation of the driving moment, so we may not consider the W2 because W2 times 0, it becomes 0. Okay. So for this example, okay, for the first one, resisting moment, it is a same concept. Okay, because we have two types of different soils, so we need to solve for the first one and then add for the second one, then get the value for the resisting moment. Okay, while for the DM driving moment, okay, we only consider for the W2 because W1 because W2 it is neglected as the width of the soil which one acting through the center of the circle. Okay. So the driving moment for the W2 is equal to 187,200. Okay. So to get the factor safety, RM should divide with the DM. Okay. The value is around 0.87. Okay. So you can write later on, okay, when I attach this example in the e-learning. Okay. Okay. So the last example, okay, where we have this kind of problem, with a tension crack, and also there are a surcharge on the top of the slope surface. Okay, so in this case, we have three type of driving moment. First, the weight of the slope. Okay. Second is the uniform surcharge, and third is the total is the tension crack. Okay. So then we should calculate for the resisting moment. Okay, where this opening has been reduced. Okay, where actually the opening of this circular arch is supposed to end the at the end of this tension crack. Okay, so we need to calculate what is the new opening arch, circular arch. Okay, so to get the opening size, okay, so in this example, okay, Dr. Kamarudin assumed, okay, the length of this circular arch is equal to 3. Okay, so when we look on this example, okay, actually it is a r theta, not r square theta, because the L is equal to r theta, not r square theta. So I will amend this solution, okay, and then I will give the new the correct one. Okay, that's why I'm not provide this example in your e-learning yet. Okay, so r theta is equal to 3. Okay, then we obtain the theta actually is not 0.3, but it is 7.1. Okay, so we do the calculation, 120 minus 7.1, the result is around 34,000. Okay, okay, I will do the amendment later. Okay, so 34,000. Okay. So then we have three types of driving moment. The first one is the weight of the soil. Okay, so easily we can get when we multiply the weight time with the moment arm. Okay, so we have another driving force with driving moment, which is the uniform distributed load. Okay, where the value is 50. Okay, so we need to change to the weight where 50 times 8, 400, and then times the moment arm, which is 5 plus 2 plus 8 over 2, which is 4, then the value is about 4,400. Okay, so the last is the tension crack. Okay, so how could we determine the tension crack value? First, we need to determine the PW. Okay, so the PW, due to the height of the due to the depth of the tension crack is 3 meter. Okay, so half times 10 is the unit weight of water, times 3 is the height of the tension crack, and also times another 3, which is to get the pore water pressure value at the 3 meter. Okay, so this is the weight. Okay, and then we need to get the moment arm. Okay, for this case, okay, 7 is the point from origin to the top of the slope surface. Then from 3 meter, due to the water fill full with, due to the tension crack fill full with water, so we need to use the 2/3, okay, times 3 to get the moment arm from the surface to the tension crack. Okay, so 7 plus 2/3 times 3 is the moment arm, then we obtain 405. Okay, so in total, okay, the factor safety, the new factor safety is supposed to be 1.0 something, not 1.12. It is still greater than 1, but it is less than 1.5. Okay, okay, so that is the sum of example on Dr. Kamarudin reference book. Okay, so I will not go to DAS example. Okay, because it's not stated on the total stress. Okay. Okay. So any question? But before we end, I need to share the attendance list. Okay. If you have any question, you can ask now. Okay. Because I need to create the Google form first. Okay. No question.
Clear, clear.
Tak ada. Okay, kejap Okay, when I'm creating the Google the Google form. Okay, this is for MEAJ 1043. Okay. Okay, this is for SKAB 5733 of is it 5733?
SKB होता है.
SKB 5733
Yeah.
Awak tu nanti saya betulkan. Okay.
Sorry, Prof. The second one for 1073?
The first one. The second
okay,
is for
thank you, sir.
5733. Or
Okay.
if you open, it is 5733, so you need to open another one.
Okay, Prof.
Okay. Okay, with that I end our today class. Okay, I will share the Dr. Kamarudin example. Okay, and also we share I will upload the recorded version, okay, in the e-learning. Hopefully by tomorrow, okay, because tomorrow I will go to the UTM. Okay, okay, okay. Salam.